Hi, in this video we will introduce our design, Emotion Light. Creativity support tools have been a subject of research in the past years. Unfortunately, an area of tools for modern performance art has received limited attention. Traditionally, artists have relied on using conventional mediums such as paint, paper, and physical artifacts. We observed that a key characteristic is that artists in the process of performance have their hands occupied, either due to controlling complex drawing tools or gesticulation itself is a part of the performance. So hand-free interactions will create more novel forms of performance. Also, the traditional approaches of using pre-recorded light do not allow the artist to deviate from this scenario. Alternatives of using a lighting system operator are limited in the way, such as operators not understanding the meaning of the promptu and not being able to respond with adequate lights. Therefore, impromptu expressions allow the artist to adjust their performance according to their inner state or audience response. Lastly, the forms of art performance are diverse, and light projections increase the number of possibilities the artist can express themselves. Looking more closely, artists can surprise the audience by hiding some aspects of painting by projecting light colors that camouflage a paint color, for instance. In our design, we aim to create the first prototype of a tool for artists that is suitable for specific arrangement in the performance of painting art. Here we're presenting Emotion Light, and it allows artists to include light projection in their performance while being hand-free and allowing for promptu. Before the performance, artists will need to set up the configuration through the control interface. There are 8 emotions available, and artists can set these emotions as different colors with desired brightness. When configuration is done, artists are able to see the reflection of their facial expressions. Now, let the show begin. The emotion light can impact the effect of art performance. This artist is drawing a picture of a tree. The leaves are painted as gold color. Now, he is showing a sad face to make these golden leaves disappear visually through the light projection. Also, the emotion light can help artists express their feelings more vividly. This artist is drawing a bare tree stem in the winter. He's using a neutral facial expression to intrigue light projection of cold blue color. To simulate the vibrant spring, he is showing a happy face with a smile. For summer, he chose red color to express his anger and passion in this season. When the autumn is coming, he's full of sorrow of passing time. A sad face tells the audience this is a sentimental season. Now, let's talk about system implementation. The user interface is built using the Qt Python library that allows programs to run on Windows and Mac systems. The GUI interface is used to launch, stop, and configure emotion to color mapping and the brightness of a mapped color. Further, GUI allows the user to see whether his face is within reach of the camera. We have adopted a webcam as input. The face expressions are captured using a MacBook Pro inbuilt video camera. The face images for later process are captured using a Python application written by our team that uses OpenCV library to read a video stream and retrieve frames. In the step of processing, there is a middle layer between input and output that transforms captured face images into projected RGB light. At the first step, our system sends captured face images transformed into a string to Azure Cognitive Services. After each call of API data in JSON format is returned, each response consists of attributes for each emotion and the level at which emotion is expressed. Subsequently, 2 most significant retrieved emotions are mapped to color based on the user's configuration and emotion intensity. In the last mapping step, these 2 colors are combined using the OpenCV library, which results in the one color saved in the RGB format. The resulting color is then sent by the Python program to the Arduino so that the light can be projected by the LED strip. At the first step, the Python program sends a poster request to the Arduino through a local Wi-Fi network. In the parameters of the request, there are 3 values, each representing an RGB measure. The Arduino uses the request parameters to set up corresponding RGB light and project it through the LED strip.